Yes, welcome to this part 1 of CV312 Lab 5 demonstration. So this week's lab exercise requires us to do 2D fracture analysis with a plate, rectangular plate, with a crack in the middle of it under a uniform tensile load. Now, we are required to determine the stress intensity factors, which are K values. And we are expecting those K values to occur at the edges of the cracks and the sharp corners. Now, when we approach a problem like this, and for this lab exercise, we will be using symmetry boundary conditions. Why symmetry boundary conditions? Because we can see that the geometry is symmetrical about the x-axis, and the loads as well as the geometrical symmetry is present about the y-axis. So we will be actually modeling a quarter of this whole plate and not the whole thing. The reason for this is we can get the same results that we would expect from modeling the whole plate by just modeling a quarter, and it will be done in a much shorter processing time. Okay, so to begin with, we will go and open up our Ansys software. So start, go to Ansys R1, scroll through until you come to mechanical APDL. Now we've entered the software. Okay, so before we start, we'll go to save and we'll change the job name. So this job name will be MM312. We'll click OK. Then we'll go to File, Save As, and we'll save this as Central Crack DB. We'll specify that we want to save it on our desktop. We'll click OK. Right, brilliant. So now we have created a new file and we have saved its file paths. We can also go to File and change title and change it to Central Crack. OK, then go to Plots and Replot. Now we have a job title, Central Crack. The first thing we have to do is we have to set our preferences to structural analysis. Okay. Then we'll go to preprocessor, element type, add, edit, delete. We'll add a new element type, and for this analysis, we'll use solid elements. We are making the assumption that we're only interested in plane stress. Okay, we're not interested in the third dimension of stress, which is the dimension of the stress through the thickness. And this is because we are only expecting the stress intensity factors to be showing in the XY plane and not through the Z. We're expecting it to be constant through the Z. So we'll select solid elements and choose 8 node. Why 8 node over 4 node? Because 8 nodes will give us more definition and more accurate results. Then we'll click OK. Now in here we can go to options and we can see the types of results we'll be getting from using this element. Okay, there's multiple options. We can go plane stress, asymmetric, plane strain, all that. Like I said, we're going to use plane stress. So we'll keep everything as it is and we'll just click OK. And we can close this dialog box. So we've specified our element type. Now we can go and specify the material properties. But before we do that, let's set our units. So command prompts /units. Enter. To check whether or not we've changed the units, we can go down to our output window. You can see that we've set the units to SI. Now let's go to material properties, material models, structural, linear, elastic, isotropic. We'll set the Young's modulus to 200 pascals and the Poisson's ratio to 0.3. Click Okay. Okay, so we've defined the element type, we've defined the material properties. Now we can jump into modeling. So to do that, we will plot our key points. Preprocessor, we'll go to modeling, create key points in the active coordinate system. And similar to your previous lab exercise, we will input the key point number along with its coordinates. Hit apply, and then we'll change the key point number and change its respective coordinates. Note that we are only entering the x and y values and not the z values. When we reach the last node, we can click OK. So we've set up our 5 key points, 1, 2, 3, 4, 5. The next step is to join them all using lines. So we'll go to create, lines, lines again, and we will select in active coordinate system, and you select key point 1, key point 2, then key point 2, key point 3, key point 3, key point 4, key point 4, key point 5, and then key point 5 back to key point 1. And click OK. To display the line numbers, we go up to control plots, numbering. We'll turn on key point numbers as well as line numbers. We'll click OK. Then we'll go to plot and multi-plots. So we can now see all of our line numbers as well as our key point numbers. The next step is to create an area within the next step, we will break down lines 3, 4, and 5. So we'll go to main menu, again, main menu, preprocessor. We'll go to meshing this time, which is here. We'll go to size controls, manual size, lines. We'll go to pick lines, and now we'll select lines 3 and 4. So lines 3 and 4. We'll click OK. And we'll set the number of divisions to 4. Then we'll click apply. Similarly, we'll then select line 5. Okay. We will enter 6 divisions and a spacing ratio of 0.2. Once we have that, we can click OK. So now we've broken each of our lines up into segments. This will help us when we start to do our mesh. Now we will create a concentration key point, and this is the edge of our crack. We're expecting the maximum intensity factor, stress intensity factor. So we'll go to main menu. This is the main menu. Processor, meshing, size controls, and we'll go to concentrate KPS. We will create, and we will select key point 2. Then we'll click OK. In the window below, we will see these bits of information. In the second column, in the second row, we will enter 0.0025. And we will set to skewed quarter part. Then we click OK. Now we can create the area within the shape, within the lines that we have already defined. So we will go main menu again, preprocessor, modeling. We will create, and we will create areas. We will select arbitrary, by lines, and we will pick all 5 of the lines that we've created. So line 5, 4, 3, 2, and 1. Then we will click OK. Your window should look something like this. Remember to save as you go along. Okay, overwrite, yes.